Solving quadratic equations using the square root property. By the square root property. So a quadratic equation in the form ax squared plus bx plus c equals 0. So the only time we can do the square root property is if there is no bx term. Or sometimes this is stated if b does not equal, if b equals 0. So if b is 0 or there's no bx term. So it's only when I just have the ax squared term, the constant, and an equal sign. So what the square root property says, if I have something like this, square root property, what it says is that if a squared equals b, so I know I'm kind of using a differently and b differently in my rule now, but just pretend a is anything coefficient or x, b is anything, typically just a number. So if a squared equals b, then to get a, to get a alone, I would want to get rid of the square root, or the square, which the opposite of squaring something is taking the square root. So a is the square root of b, but it's not just the square root of b, it's plus or minus the square root of b. And before we really do want to make sense of this, let's say I have something squared equals 9. Okay, so if I think about this, well, 3 squared is 9, but also 3 squared is 9, but also negative 3 in parentheses squared is 9. So really, in this situation, x is a positive 3 and a negative 3. So that's kind of why we have this rule. So let's say, for example, I want to solve the equation x squared minus 25 equals 0. So here I have something squared, I have a constant, so it's a quadratic equation, but there is no x term. So I can use the square root property. So what I want to do is first make it look like this, a squared equals b. So I'm going to add 25 to both sides so that the x squared part is alone, and I have my constant on the other side. So now, when I take the square root of both sides, square root of x squared, square root of 25, I get x on the left side. Now, it's not just the square root of 25 though, it's plus or minus the square root of 25, which is 5. Okay, so this should make sense a few different reasons. If I plug in 5 squared, let's do a check. So if I plug in 5 squared minus 25. Okay, so that's 25 minus 25, yep, that's 0. Or if I plug in negative 5 squared is 25 minus 25, yep, that's also 0. So they both check out. The other reason this should kind of make sense is, let's think about x squared minus 25. If I factor that, that factors into x plus 5, x minus 5. So if this is equal to 0, then using the 0 factor property, x would be negative 5 or positive 5, doing it that way. So regardless though, I get two answers, a positive 5 and a negative 5. So using that plus or minus shows that. Okay, let's do another one. How about 7x squared plus 2 equals 23? Okay, so my first step is to isolate that x squared. So I'm going to subtract 2. 7x squared equals 21. Divide by 7. X squared equals 3. Okay, so that's important to first isolate the x squared part. As long as there's no x term. In this problem, there's no x term, so I can be doing this square root property. So now that I got the x squared completely alone, dividing by the coefficient as well, now if I take the square root of both sides, I'm going to get x equals plus or minus the square root of 3. So now this right here, and I mean this means a positive 3 and a negative 3 square root, positive square root of 3 and negative square root of 3. So what I have right now, these answers, these are called exact answers. I could also get an approximation. So if I do the square root of 3 in my calculator, this is approximately 1.73. So positive of that and negative of that. So these are my approximate answers to the 100th place. So leaving it as a square root, that would be considered the exact answers. Calculating this, which is in reality more usable, to the 100th place, I get plus or minus 1.73.